In this section, we start probability. Some basic concepts of probability. An event is any collection of results or outcomes of a procedure. A simple event is an outcome or event that cannot be broken down further into simpler components. The sample space for a procedure consists of all the possible simple events. A quick example of flipping a coin. Simple event would be getting a heads or tails. The sample space is heads or tails, so two possibilities. Another example of flipping a coin twice. Now there are more possibilities labeled in the sample space. Now let's toss a coin 3 times. What is the sample space for this? Let's start with 3 heads. Then 1 heads and 2 tails. Now 2 heads and 1 tails. And finally, all 3 tails. Totaling all of the simple events, we have 8 possible outcomes. A cool shortcut to figure out how many possible outcomes there are . We start with how many options on the coin, which is 2. Then we think of how many times we are flipping the coin, which is 3. And of course, 2 to the 3rd power is indeed 8. Some notation. P denotes probability. A, B, and C denote specific events. P of A means the probability of event A occurring. The classical approach to probability leads to the following way to find P of A. The probability of event A happening is the number of ways A can occur divided by the number of simple events in the sample size. An example involving tossing a coin twice. Listing the sample size and listing the possible outcomes. Example A, probability of coin being heads twice is 1/4. Probability of the coin landing on heads only once is 2 out of 4. Probability of heads at least once is going to be 3/4. Another example. Here we are rolling a 6-sided die. So sample space is going to be 1, 2, 3, 4, 5, or 6. So probability of rolling an odd number is 3 out of 6. Probability of rolling a number greater than 2 is going to be 4 out of 6. Probability of rolling odd or even is 6 out of 6. Probability of not odd or even is going to be 0 out of 6. Now let's look at an example where we roll a die twice. The sample space is listed below, which is 36 outcomes. Remember the shortcut for a sample space like this? We know we are rolling a die with 6 sides. Remember the coin had 2. Very similar. Then we also know we are rolling the die twice. Again, like the coin where we flipped it 3 times. So we end up with 6 to the second power, which is 36. So answering some questions. The probability both numbers are the same will be 6 out of 36. And the probability of having the sum be 7 will be 6 out of 36. Another example involving a standard deck of 52 cards. Below is what a standard deck looks like. Once you have studied the diagram, you should be able to see the different possibilities. So the probability of picking an ace is 4 out of 52. Probability of picking a black card is 26 out of 52. Probability of picking a face card is 12 out of 52. And probability of picking a non-face card is 40 out of 52. Picking not something is called a complement. Sometimes it is easier to count the ones you don't want and then subtract. Like the previous example involving probability of a non-face card. Here is some notation for the complement. In this example, we want to know the probability that a woman is selected from all of the senators. The probability, P of W, equals 16 out of 100. Now let's use the complement to find probability of a man selected. We can use the complement of what we just found and look at probability of not a woman. Which will be 1 minus 0.16, and that is equal to 0.84. Women do not have the same chance of being selected since there are less of them. Another way to calculate probability is the use of relative frequency approximation of probability. This is done from conducting or observing a procedure and counting the number event A actually happened. These approximated probabilities tend to get closer to the actual probabilities as the total number of times the procedure is repeated increases. An example using relative frequency. Event A is going to be the microwave door breaking. In this case, since we're doing 20 trials, that is our total number of possibilities. Event A occurs 6 times. So probability that a door breaks is going to be 6 out of 20. Subjective probability uses a probability value based on an educated guess or estimate using knowledge of relevant circumstances. Here are a couple examples using subjective probability. Below is a description of the rare event rule for probability. Now we look at the addition rule for probability, which involves a compound event. Probability of A or B can be found using this formula. The probability of A and B depends on the context of a problem, so it is very important to read problems carefully. Some examples. Example A, we want the probability of picking a heart or a club from a deck of cards. Let's rewrite in probability notation. Now we use the addition rule. Probability of a heart and a club is 0. So we end up with 26 out of 52. Example B, we want the probability of a heart or an ace. Let's rewrite using probability notation. Use the addition rule to split it up. Here, probability of an ace and a heart is 1 out of 52, so we take that out to accommodate for overlap. And simplifying, we get probability of a heart or an ace is 16 out of 52. Example C, we want the probability of picking a face card or an ace. Writing in probability notation and using the addition rule to split things up, in this card, picking a face card and an ace cannot happen. And we end up with 16 out of 52. Now we want probability of a red card or a face card. Rewriting in probability notation. Here, we take away the overlap of picking a face card and a red card. And our result is 32 out of 52. More examples using the addition rule. We want the probability of rolling a 7 or an 11. So rewriting using probability notation, also, we know there is no way to roll a 7 and an 11, so that's 0. Revisiting the sample space of rolling a die twice to see how many ways to get a 7 or an 11. So we get the probability of getting a sum of 7 or 11 is 8 out of 36. Here we want the probability that the first die is odd or a pair is rolled. So again, rewriting in probability notation and using the addition rule. In this example, we take out the overlap of first die being odd and a pair being rolled. Another example. Tossing a coin 3 times, we want the probability at least one of the coin is head. Writing in probability notation. So we end up with 7/8. Now let's do this using the complement. And we get the same thing.